Hall effect. Okay, so is it clear, beta? Are you getting the screen, share screen?
जी सर.
Okay, और अगर बीच में मैं चुप कर जाऊं तो it means that I am still admitting all the students. ठीक है, so they are still coming by. So right now there are about 44 students participants, so it will take time. Okay, so what we have discussed in the cross field is that basically in cross field we have the electric field and that of the magnetic field that are perpendicular to each other, isn't it? I think this was the case behind the cross field. So again, in the Hall effect, we will use the same principle in order to find out the application of the cross field, and it has number of applications, automotive industry to manufacturing industries, even in the fabrication, chips fabrication, maybe we can use it. So how we can do it? For that purpose, I will just remind a certain phenomena. Just I will revise you. Just hold on a second. What was the cross field? Cross field was basically something like this one, in which we have, there was the electric field. Let's suppose it was directed toward the downward direction, like this one, negative to positive. Okay. Second thing was, magnetic field that is perpendicular to the electric field. So when a charged particle will pass by, obviously it will experience a magnetic force or the electric force. Magnetic force would be equal to QVB, while the electric force will be equal to QE. If both are equal, then what will happen? Equal and in the opposite direction, then what will happen? Obviously, no effect will take place on the charged particle and it will pass by without deflection. Okay, like we have discussed in the cathode ray tube. So this was just a simple VN. Now we will take this concept and we will use it in rather than a single charge particle, we will use it into the number of charge particles. Means that we will use it on NQ or NQ by T. It means that we will apply it on the current, and then we will say that how there will be a cross field and how we call it as a Hall effect and what it has the applications in the daily life. Okay, एक second बेटा फिर. So for that purpose, I need a clear.
Excuse me sir.
बेटा जी बेटा.
सर वो स्टूडेंट्स लॉग में वेट करें, फाइनली उनको एडमिट कर लें.
बेटा मैं कर रहा हूँ साथ साथ ना, तो just अब. Okay, so here we have a clear screen board. ठीक है, and ये let's suppose we have this metal strip here. Okay, this is the metal strip here, and current is passing from this end to this end. Okay, like here. So it is traveling from left to right, and a magnetic field is applied perpendicular to the center of the center or throughout the throughout the this metal strip. Okay, I am drawing a cross. It means that the magnetic field is into the paper. So throughout the strip, this is a metal strip. Throughout the metal strip, what is happening that a magnetic field is applied, okay, which is going into the metal strip, and a current is passing in the rightward direction. Okay, so what will happen that, what do you think that when a charge particle moves within the magnetic field, what happens? क्या होता है?
Reflection.
Okay, and why this reflection takes place?
The magnetic force की वजह से.
And what is the magnitude of the magnetic force? क्या relation है?
QVB.
QVB. So obviously when a charge particle moves within the magnetic field, it experiences a force that basically deflects it. Okay. So right now in this scenario, we will use the right hand palm rule, and we are not talking about current here. We are just talking about a single charge here. Okay. So if the direction of the charge particle is rightward, magnetic field is into the paper. So what would be the direction of the magnetic force? It is in the downward direction, or it would be in the upward direction?
Downward.
Okay, downward. And why is it so, beta?
सर बात रिपीट कर सकते हैं, समझ नहीं आ रही.
Okay, a single charge particle is traveling to the right direction, right side. Okay, like here, as per the arrow. Magnetic field is into the paper. Okay, using the right hand palm rule, what would be the direction of the magnetic force? It would be in the upward direction, or it would be in the downward direction? Okay, simply take your
सर
hand
downward होनी चाहिए.
downward, and in my opinion, it should be in the upward direction.
Yes, sir. What होनी चाहिए?
You will take your fingers into the paper, yani toward the laptop or the mobile. You will point your fingers of the right hand into the direction of the magnetic field. Your palm will be in the upward direction, while the thumb will be in the direction of the charge particle or the current, you can say here in this scenario. So normal of the palm would be in the upward direction. So the charge particle will be deflected in the upward direction. ठीक है? क्या ये नहीं होगा?
Sir, please दोबारा explain कर दो.
No sir, नहीं समझ आई.
Take your right hand palm. Your palm should be in the upward direction. ठीक है? Thumb will be pointed toward the direction of the charge particle, which is on the right side. ठीक है? Thumb will be in the right side. Your palm will fingers will be into the paper. ठीक है? Away from you, यानी away from you होंगी fingers. जो thumb होगा, it will be in the right direction, while the normal of the palm will give you the direction of the force. नहीं पता चला बेटा?
No sir.
Sir, upward.
लग गई है.
Just your fingers will be in the direction of the magnetic field. It is difficult to draw three dimensions here. ठीक है? So I will make it. Thumb will be in this direction. Palm जो होगा आपका, obviously जो right hand का palm है, उसका normal would be in this direction. अब clear हुआ आपको? This is the fingers, this is the thumb, and the normal of the palm will give you the direction of the magnetic force.
Yes sir, ठीक हो गया.
Fingers को आप किस डायरेक्शन में रिप्रेजेंट करते हैं?
Magnetic field.
Magnetic में.
Obviously, and thumb is in the direction of the charge particle या उसकी velocity में, or on the other end, force will normal of the palm will give you the direction of the force. So I am talking about the charge particle here. I didn't talk about the negative or the positive. So normally we will assume that we are talking about the positive charge particle. Okay. So it means that the direction of the force will be in the upward direction. ठीक है, for the positive charge particle. ठीक है, so it means that positive charge particle will lie in the upward direction. एक सेकंड दीजिएगा मुझे. Positive charge particle would be in the upward direction. So what would be the force on the negative charge particle?
Downward.
Obviously. ठीक है, so negative will be in the downward direction. ठीक है, clear हो गया up to this point? Any question?
Clear है sir.
Clear. Okay, in this way, ये तो एक single charge particle we are talking about. ठीक है, now if we have number of charge particles, ठीक है, so in FSC you have studied क्या था कि F is equal to Q VB. ठीक है, or I can write it as, because I have n number of charge particles, so I can write it as NQVB, or I can write it as capital Q L by, एक second, L by T. Velocity I have written velocity as L by T. Velocity क्या होती है? S is equal to VT, V is equal to S by T, and in this case the distance is obviously L, length of strip is L, so I am writing it as L by T. So can I write it like this one? लिख सकता हूँ बेटा मैं ऐसे?
जी सर.
Is this question okay for you?
Yes sir.
Yes, sir.
Yes sir.
Why I have written it like this?
तो मैग्नेटिक
Basic-
ड्यू टू करंट की वजह से होगी.
बिल्कुल. The thing is कि basically what you have studied in FSC was inverse of this one. You started from ILB and you came to the QVB. I think it was like this in the FSC. But
Yes, sir.
here I have started on the wrong way side. So the reason is because previously when we were talking about QVB, we were talking about a single charge particle. But when we have a number of charge particles in a current, we have number of charge particles. So I have written it like NQVB. So NQVB can be written as a total charge which is equal to Q, while the velocity can be written as L by T into B. And in this way, if we have a current, we can use the same phenomena in order to find out the force that is acting on a current, and that would be equal to ILB. So for that purpose, what will happen that now if we have a number of charge particles, so in that scenario, okay. In that scenario, case should be something like this one here. Okay. So now think here that now the positive charge particles are getting the reflection on the upward direction and negative charge particles are getting on the downward direction. So what would be the direction of the electric field here? So the direction of the electric field would be in this side. ठीक है? यही होगी ना electric field.
जी sir.
Yes, sir.
Okay. Okay, now you can see here that there is a electric field between the two ends of a strip, and this electric field is perpendicular to the magnetic field, because magnetic field is into the paper while the electric field is like here parallel to the width. So these two are perpendicular to each other and they are basically creating the cross field. ठीक है? They are creating the cross field. Aren't they? क्रॉस फील्ड की समझ में आ गई?
जी सर. Yes sir.
ठीक है. So this overall effect is known. बड़ा इसमें deeply concepts हैं, couple of others too. ठीक है. But problem ये है कि you have I think चले मैं आपको थोड़ा सा आपको मजीद इसको एक्सप्लेन कर दूंगा. सो अप टू
Yes.
दिस पॉइंट, ठीक है, you are getting the okay the perpendicular cross field, ठीक है. No, the overall effect is known as the Hall effect, because it means that when you are placing a current carrying strip into the perpendicular magnetic field, it will create a perpendicular electric field, ठीक है. That would be again perpendicular to both electric field and that of the current, and as a result the overall effect is known as the Hall effect. So overall, this is the main concept of the Hall effect. So this is how you can say that Hall effect can be created, and this potential, this electric potential is known as the Hall potential. ठीक है, इसको जो electric field create हो रही है because it is creating the potential difference between the two ends. So it is basically known as the Hall potential. ठीक है, अब आ जाते हैं concept के तरफ के how I am getting the positive charge and negative charge when I am taking the metal strip here, because I do know that in the metal strips or in the metals or in the conductors there are only one type of the charge carrier. So how I am getting both positive charge carrier or the negative charge carrier? If I am talking about the silicon or the semiconductors, okay, I can say that okay, I have both charge carriers, positive and that of the negative. Means that holes and electrons I have both charge carriers in the semiconductors. But in metals, how I am getting the both charge carriers? ठीक है, both positive and that of the negative. I can either take positive charges or I can take negative charges, which is the electrons. For the conventional point of view, I will always take positive charges. But if I am talking about the electronic current which actually take place in the conductors, so I will only take the negative charge carriers. So here I am taking both of them. If I am talking about the metal strip, so how I am taking both of these charge carriers in a conductor? कैसे किया मैंने? कैसे I am getting the positive and I am getting the negative here? कैसे हो सकता है?
Sir, holes.
कोई any person who can give me answer?
सर मुझे
Okay.
नेगेटिव इलेक्ट्रॉन्स की वेकेंट स्पेसेस हमसे है.
Deficiency, what does mean by the deficiency? ठीक है, to some extent you are saying right, but how deficiency? Normally when we are talking about in the semiconductor, we say okay, there is a deficiency of the electrons. It means that there are holes, but here how there are holes? There cannot be any hole here. क्वेश्चन आपको समझ में आ गया बेटा?
No, sir.
My simple question is that this is a metal strip and how I am getting both positive charge carriers and negative charge carriers in a conductor, because conductor can only have one type of charge carrier. क्या कहते हो यार? कोई गलत ही आंसर दे दो. सिंपल आंसर है, ठीक है, लेकिन उससे पहले मैं आपको एक चीज बताता हूँ.
सर
Okay.
मेटल में तो ही इलेक्ट्रॉन्स होते हैं.
ओनली इलेक्ट्रॉन्स ही होते हैं ना बेटा, ठीक है. सो देन हाउ वी आर गेटिंग द पॉजिटिव चार्जेस हियर, ये मैं पूछना चाह रहा हूँ कि एक साइड पे पॉजिटिव ले लिया और एक साइड पे नेगेटिव ले लिया. इवन एट योर होम्स, ठीक है, क्या हो रहा है आपके पास? यू आर यूजिंग कॉपर वायर्स एंड यू आर टेकिंग वन एज a zero and other one as a negative and other as a positive. कभी सोचा आप लोगों ने? अच्छा, जस्ट मुझे ये बताएं, पोटेंशियल डिफरेंस है, ठीक है. अब ये देखें, मुझे ये बताएं आप कि विद रिस्पेक्ट टू आपके पास आता है, मैं आपको कैसे इसको एक्सप्लेन करें? चलें एक सेकंड बेटा रुकिएगा. वन पॉजिटिव है कि टू पॉजिटिव है नॉर्मल केस में आपके पास? या whenever you are taking the potential, lower potential को आप क्या लेते हैं? You always take a negative, while higher potential you take it as a positive. So 1 is positive or 2 is positive here?
Sir, 2 होना चाहिए.
2 is positive.
2 positive.
2 positive. Okay, no. 0 is positive or 1 is positive?
1.
1. Okay. -1 is positive or 0 is positive?
0.
0 is positive.
0.
Okay. -2 is positive or -1 is positive?
Minus
Which one
1.
is
-1.
Minus
Okay.
1.
Okay. Now here you can see that at one point, there was some person who was saying okay, deficiency of electron. Deficiency of electrons means basically lesser concentration of the electrons. Okay. So when electrons get deflected at this point, so what is happening that there is more concentration of the electrons at the bottom end. So it is creating -2 charge here, while it is creating -1 on the upper direction. So one will act as a positive and other will act as a negative. So in this way, lesser concentration of electron will be called as a positive, while the higher concentration of the electron will be called as a negative. So now it is clear to you?
जी
Yes,
sir.
sir.
Okay. अब आ जाते हैं नेक्स्ट क्वेश्चन की तरफ. नो द नेक्स्ट क्वेश्चन इज कि इन दिस वे व्हाट शुड हैपन कि इलेक्ट्रॉन्स तो सारे इस तरफ हो जाने चाहिए. ठीक है. नो दे आर गेटिंग द डिफ्लेक्शन. मतलब आपके पास क्या लग रही है? ILB force is acting on the electrons and electrons should move in the downward direction. All electrons should move in the downward direction, but it does not happen. ठीक है. All electrons cannot move in the downward direction. क्यों?
सर क्योंकि उनके ऊपर फोर्स लग रही होगी.
Force लग रही है. Magnetic force is acting on them. ठीक है. And it is deflecting them in the downward direction. But all electrons cannot go in the downward direction. क्यों? क्या हो सकता है? Simple is that. Simple answer क्या है आपके पास? Up to this point, ठीक है. आप just ये करें कि I am talking up to this point. ठीक है. ये आपके पास point है. There was a single electron. ठीक है. It was moving in the down. Previously there were no electrons at the bottom end. Let's suppose. So what is happening when electron came into this strip? It experienced a force which moved it into the downward direction. ठीक है. So it occurred there. No magnetic force still exists. Now what is happening that second electron will come by. ठीक है. So magnetic force is moving it into the downward direction. Okay, fine. But what is happening now? ILB is moving it into the downward direction, but the Coulomb force of repulsion, which is equal to QE, is moving it, basically repelling it, because both are negative charges. So Coulomb force of repulsion will repel it. But since the magnetic force is larger, so it will still hold it in the downward direction. Same phenomena will take place with the third one. But when the fourth charge will come by, let's suppose fourth charge will come by. Now at this point, the Coulomb force of repulsion that is acting due to these charges becomes equal to ILB. Now what is happening that these charges, no more charges or no more electrons will come in the downward direction, because if the magnetic force is pulling it, forcing them into the downward direction, the Coulomb force of repulsion is basically repelling it in the upward direction. Since both are equal, so no more charges will come in the downward direction. So in order to increase the Hall potential or the number of charges at the bottom end, so you have to increase the magnetic force, and that can be increased by either increasing the current as per this equation, or by increasing the length of the strip, or by increasing the magnetic field. Is it clear, beta?
जी sir.
चलो. So this is the whole phenomena behind the Coulomb Hall effect. ठीक है. So I don't think so that they have discussed in detail within the टेक्स्ट बुक. सो लेट्स सी कि उन्होंने क्या वहाँ पे डिस्कस किया हुआ है. एंड दिस इज द मेन प्रिंसिपल बेटा. एंड anyone, if anyone has any question up to this point, he can ask me right now.
सर ये एक बार फिर एक्सप्लेन कर दें.
ओके. सिंपल आप ये दें कि आप क्या कर रहे हैं कि यू आर अप्लाइंग द मैग्नेटिक फोर्स. ठीक है, मैग्नेटिक फोर्स इज मूविंग द इलेक्ट्रॉन्स इन द डाउनवर्ड डायरेक्शन. ओके. सो प्रीवियसली जी बेटा, previously there were no electrons in the downward direction. Okay, so nothing will happen, the electron will move in the downward direction. But when next electron will come by, so the magnetic field will force him to move in the downward direction. But since there is already existing charge particle, so what will happen that it will repel it, because both are negative charges. So Coulomb force of repulsion, which is equal to F is equal to QE, will repel it. But since the magnetic force is larger, so then the Coulomb force of repulsion, so it will remain in the bottom direction. Again, the third charge will come by and it will remain in the downward direction. But when the fourth charge will come by, now the Coulomb force of repulsion become equal to ILB, and as a result, no more charge particles will move to the downward direction, because the force with which the magnetic force with which it is forcing the electrons to move in the downward direction, the Coulomb force of repulsion is basically forcing it in the upward direction. अब क्लियर हो गया बेटा?
Yes sir.
Okay. चले बेटा. So up to this point, we will now start toward the what the book says here. जी बेटा.
सर एक और बात कंफर्म कर लें. सर देखिए ये स्ट्रिप हमारे पास एक सर्टेन लेंथ की है ना, तो फिर अगर शुरू में ही जो सारे इलेक्ट्रॉन्स है वो डाउनवर्ड पहले आए और उसके बाद सारे अपवर्ड चले गए, तो फिर ये साइकिल चलता रहेगा अप और डाउन का.
बेटा इलेक्ट्रॉन्स विल नेवर मूव इन द अपवर्ड डायरेक्शन, ये याद रखिए. अपवर्ड डायरेक्शन में कभी भी नहीं जा सके, बिकॉज क्या होगा,
की वजह से जो भी
रिपल्शन, मतलब हाँ जी, रिपल्शन मींस के आपके पास है कि सर्टेन इलेक्ट्रॉन्स विल मूव इन द डाउनवर्ड डायरेक्शन, अदर विल मूव इन द स्ट्रेटवर्ड डायरेक्शन. ठीक है
सर.
जी जी
सर ये जो इलेक्ट्रॉन रिपल्शन है सर, ये ओवरकम तो नहीं करेगी एक एट अ पॉइंट मैग्नेटिक फील्ड को?
it can never increase the magnetic force. ठीक है, क्यों नहीं कर सकेगी? magnetic force is the only thing that is forcing the electrons in the downward direction. ठीक है, आपकी एक सर्टेन वैल्यू से ज्यादा वो फोर्स नहीं कर सकेगा, क्योंकि कूलम्ब फोर्स ऑफ रिपल्शन बिकम इक्वल टू दी ILB. अब वहां पे कोई ऐसी चीज नहीं है कि आप कूलम्ब फोर्स ऑफ रिपल्शन को ज्यादा कर सके. ठीक है, ज्यादा आप कैसे कर सकते हैं? जब आप इलेक्ट्रॉन्स को डाउनवर्ड करेंगे. जब आप इलेक्ट्रॉन्स को डाउनवर्ड ही नहीं कर पा रहे, तो आप कूलम्ब फोर्स ऑफ रिपल्शन को ज्यादा नहीं कर सके. कूलम्ब फोर्स ऑफ रिपल्शन उसी वक्त ज्यादा होगी जब आप ILB ज्यादा करेंगे. देखिए ना, एक इलेक्ट्रॉन यहाँ पे आया. ओके, क्लियर है कि मैं डिटेल में समझाऊं बेटा?
जी सर, ओके ओके
ओके जी बेटा. अब आ रहा था क्वेश्चन, आपने बेटा जो किया था, क्वेश्चन ये किया था मेरे से कि ठीक है कि इलेक्ट्रॉन्स विल मूव इन द बॉटम में आ जाएंगे, देन दे विल मूव इन द अपवर्ड डायरेक्शन एंड देन दे विल मूव इन द डाउनवर्ड डायरेक्शन. नो, it will not take place like this one. ठीक है, because the electrons will always face a force that is in the downward direction. The only thing that is varying here is the Coulomb force of repulsion. After some time, the Coulomb force of repulsion will become constant, because at that time it will become equal to QE. ठीक है, QE के जब बराबर हो जाएंगे तो आप क्या होगा कि the Coulomb magnetic force will try to move it in the downward direction, but the Coulomb force of repulsion will not allow it to move in the downward direction. They will pass in a straight line rather than in the downward direction, just like in the cross feeds when we have studied in the cathode ray tube, that when QE becomes equal to QVB, then the particle will pass straight through it. ठीक है, neither it will be deflected in the upward direction nor it will be deflected in the downward direction. This is what we have studied in the cathode ray tube when we were discussing about the cross field. ठीक हो गया बेटा?
Yes, sir.
हाँ, फिर अगर आपने कंसंट्रेशन, इफ यू वांट टू इंक्रीज द हॉल वोल्टेज, तो आप हॉल वोल्टेज कब इंक्रीज कर सकेंगे? देन व्हेन यू विल इंक्रीज द मैग्नेटिक फोर्स. जब आप मैग्नेटिक फोर्स को ज्यादा करेंगे, फिर अगेन क्या होगा कि मजीद चार्ज पार्टिकल्स दे विल कम इन द डाउनवर्ड डायरेक्शन. ठीक है, आफ्टर सम टाइम अगेन क्या होगा, दैट फोर्स and the Coulomb force of repulsion will again become equal and again the remaining charge particles will pass straight by. ठीक हो गया बेटा?
Yes, sir.
सर मीटिंग
चलें।
फिर से स्टार्ट कर लें।
फिर से ओके बेटा, 1 मिनट रह गया. ठीक है बेटा, so we will start then.